Okay, Year 12, we're back again, and we have another video here to do with our data and statistics. We are looking at outliers today. Now, previously, whenever we have described outliers, we have generally, we've sort of said, oh, well, it's a fair bit bigger or smaller. We're going to impose a condition on this now. We are going to put a strict rule, and we're going to say that we work out the interquartile range, which we find by subtracting Q1 from Q3. Right? Remember, we get a 5-number summary. Find our quartiles. Q3 minus Q1 is the interquartile range. Now I take that interquartile range, multiply it by 1.5. Right? Now that's going to be the sort of condition that we impose. And we say if I have a score that's 1.5 times the interquartile range less than Q1, or 1.5 times the interquartile range above Q3, then that is an outlier. Okay, so let's just make up a box and whisker plot. All right, we know our box and whisker plot looks something like this. Yep. Now, that's Q1. That's Q3. And this distance here, hey, this distance here is the interquartile range. Now, if I go 1.5 times that, right, from Q3, if I go up to here, that's sort of my acceptable range. And if I go 1.5 times, so that's 1.5 times the interquartile range. If I do the same down this side, if I go 1.5 times, let's say that goes to here, 1.5 lots of the interquartile range, right? This is sort of acceptable. 1.5 times interquartile range below Q1 or above Q3. That means that, right, if that's my lower extreme, then that looks like that must be an outlier because it is below this limit here. Right, we don't normally draw these with picture. We are going to measure them. So you've got to work out the interquartile range, multiply it by 1.5, subtract it from Q1, add it to Q3, and see how we go. So let's try that. Here's a set of scores. There are 21 scores there. And fortunately, they're in order for us. So if I put this into two groups of 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, let's take this score here, that 12 there out, and that should leave me with 10 on this side and 1, 2. You're kidding me? Hang on. Tricked you. Nah, tricked me. There are 22 scores there. So 11 in each group, right? This is the bottom 11 scores, this is the top 11 scores. Right, so that's the median there, somewhere between these two 12s. Median is 12. Now, out of this group of 11, I'm going to put it into two groups of 5. 1, 2, 3, 4, 5. Right, I'm going to take this one out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Take that one out. 1, 2, 3, 4, 5. Okay, so you can see there, I have 4 groups of 5. They are my 4 quartiles. Also, this is Q1. This is Q3. So my interquartile range equals the difference between 11 and 16. How far apart are they? They're 5. 1.5 times my interquartile range equals 7.5. Now, 11 minus 7.5, right? That's Q1 minus the interquartile, minus 1.5 times the interquartile range. 11 minus 7.5 is 3.5. So, 3.5 or below? Or below 3.5, any score below 3.5 would be an outlier. No outliers down here. Let's try the same thing up here. 16 plus 7.5. Okay, so we go 1.5 times the interquartile range this way, 1.5 this way. 16 equals 23.5. Woo, that makes my 25 an outlier. 25 is an outlier. Right, seems a little confusing at first, but truly not that bad. Righto. Now we've got another example here. Another example sure looks like it's going to be an outlier, doesn't it? Right, I'm tempted not to even calculate it. So what we're going to do is the mean, the mode, and the median. First of all, mode, 39. Right, mean, we're going to have to work that out in our calculator. The mode is 39. My median We're going to work it out. Now remember, punch these numbers into your calculator, right? Work out the mean. We'll work those things out. Now, presumably, we need to work out the interquartile range, but look, my interquartile range can't be more than 4. Well, in fact, yeah, my interquartile range, yeah, it can't be more than 4. 1.5 times that's going to be 6. 6 above here. Oh no, I'm going to have to do some calculations. Righto, I'll have to do the calculations to work out what our outlier is. We can't just go, well, that's an outlier. We have to use our calculations. It's going to take me a moment. Hang on a tick. We'll be back. Righto, I'm back. I grabbed my calculator, did a couple of calculations, and we got the mean. Right, the mean's 38.2 and something else. I ran it off. The mode and the median. Okay, we've got these things. I also, because, you know, I've got the Casio, I worked out Q1, Q3. The data was already in there. Right, that's nice. Just sort of saves me doing those things. And so we can see our interquartile range is 2, 1.5 times the interquartile range is 3. Q3 plus 3 would be 42, right? Here. So that makes 43 an outlier, but only just. It was very tempting. If you just saw a 42 there, you'd be inclined to call it an outlier, but I don't think you'd be right. So what do we got here? So what is the outlier temperature? 43 degrees. Right, now, if I did the same thing, just to be, you know, certain, take 3 away from this, it's 34. Score of 34 would be my cutoff for outliers there as well. Anyhow, calculate the mean, mode, and median for this data if the outlier is excluded. Right, do it again. Well, you know what? I've put the data in my calculator. You just go back to your data, right? Remove, all right, if you've got the Casio anyway, otherwise you're going to have to do it again. Remove the 43 from that data set, and you're ready to go again. So, of course, your mean is going to change a little bit. And my mean is now 37.8. Right, it changes, well, significantly. There's a lot more than other things. The mode is not affected by an outlier. So the mode remains, what was it? Hey, come on. Don't do that to me. The mode is 39. Right, it hasn't changed. And the median, well, the median can change. Sometimes it will, sometimes it won't. Right, it doesn't change very much is what it means. Is 38. So sometimes it will change by, you know, a position or two. Right. So the median stays the same. So the median has stayed at 38. So what effect does the outlier have on the measures of location of distribution? It has a large impact, relatively. On the mean. No impact on the mode. Because by definition, pretty much, but yeah, an outlier can't be the mode. Right? That would be a really weird data set where there was a group of outliers, what we classified as outliers that turned out to be the mode. Shouldn't really be outliers in that case. No impact on the mode. Minor, if any impact on the median. Right, because we have this sort of democratic kind of approach with the median, that really big score, well, it does take one score away from the list, right? And so that shuffles the position of the median half a spot, either to the left or the right, depending if it's a big outlier or a small outlier. Every time we take one off, it'll move it a little bit. But if you've got a cluster of data in the middle, if your mode is close to the center, and it generally, you know, normally distributed, it's quite common for that to be the case, then probably the median won't change, or if it does, only a tiny bit. Anyhow, that is outliers and, what's going on there? Outliers and their impact, right? 1.5 times the interquartile range above and below, I'm not responding. 1.5 times the interquartile range above and below Q1 and Q3. Thanks, guys.